Today, we're talking about a bridge that by all accounts should never have been built, the Chenab Bridge. I mean, this thing is a true engineering marvel. So the big question is, how on earth did they pull it off?
You know, that one sentence just says it all, doesn't it? It perfectly sets the scene. We're not talking about just a tricky place to build something. We're talking about a place that is fundamentally, actively hostile to human beings.
So you've got this epic story of human ingenuity, of really pushing the limits. And it's all happening against one of the most extreme, most unforgiving backdrops you could possibly imagine.
All right, so first things first, to really get what makes this bridge so special, you have to understand the sheer, insane challenge of the location itself. I mean, before they could even think about laying a single piece of steel, the team had to go head-to-head with Mother Nature. Seriously, just try to get a mental image here. This is not your average construction site with a few porta potties and a food truck. We're talking jagged cliffs, plunging canyons, no roads, no motorways, and absolutely nowhere to find a single flat, stable piece of ground.
And you know, as if that terrain wasn't a big enough problem, the project also had to deal with a whole laundry list of powerful natural forces that seemed dead set against it.
Okay, so let's break this down. You've got these insane temperature swings, from scorching 50 degrees Celsius down to freezing. Then there are these ferocious winds whipping through the canyon. The mountains themselves are seismically active. They're still moving. And the rock? It's fractured, crumbly, just totally unstable. Now, what's really wild is how all these things feed into each other. Like, those temperature swings, they're not just uncomfortable for the workers. Imagine 30,000 tons of steel constantly expanding and shrinking. It makes getting anything to line up perfectly an absolute nightmare.
And about those crazy winds, there's a reason they're so powerful. It's something called the Venturi effect. Basically, the canyon acts like a giant funnel. As wind gets squeezed through that narrow passage, its pressure drops and its speed just skyrockets. It's like a natural wind tunnel on a massive scale.
165 miles per hour. Let that sink in. That is the kind of wind speed you'd see in a major, catastrophic hurricane. Now imagine you're hundreds of meters up in the air, trying to move a massive chunk of steel into place with that kind of force just hammering you. It's unbelievable.
Okay, so with all that, the wind, the quakes, the crazy temperatures, you'd think one of those would have to be the biggest problem, right? But here's the crazy part. The truth is, all of those challenges, as huge as they were, actually paled in comparison to something much, much more basic. So what was it? After everything we've just talked about, what could possibly have been the single biggest challenge? Simply getting there. That's it. The isolation of the site was so extreme that just reaching it became the project's #1 engineering problem. And listen to this quote from one of the lead directors. It just brings it all home. He said that on their first trips up, they actually took a boat because it was literally faster to go down the river by boat than to try and navigate what they were calling paths. We're talking about using donkeys to haul gear up mountain streams. It's just wild. So get this. Before they could even start on the bridge, they had to complete a whole other massive engineering project first. They had to build 26 kilometers of brand new roads. And these weren't just simple country roads. They were literally carved into the sides of mountains, just clinging to the cliffs, all to get people and materials to the work site. Okay, so the challenges were, let's be honest, almost unbelievable. But now we get to the really good part. Let's talk about the absolutely ingenious solutions that conquered this canyon and made this whole thing possible. So, why an arch bridge? This was probably the most important decision they made. See, if you tried to build a standard bridge with big towers going straight down into that V-shaped canyon with all that unstable rock, well, the towers would just slip and slide right down into the valley. It'd be a disaster. But an arch? An arch is brilliant. It takes all the weight and pushes it down and out, right into the solid rock of the mountain itself. It basically locks the whole thing in place, making the mountain part of the bridge's foundation. All right, so here's the next million-dollar question. How do you get 30,000 tons of steel to a place with no roads? The simple answer is you don't. Instead, you ship it in flat-packed, like the world's biggest, most complicated IKEA project. Then you build enormous workshops right there on the edge of the canyon to cut, drill, and assemble every single piece on site. Incredible. And building this thing in midair? It was a logistical masterpiece. First step,
They built this huge cable crane system, basically an aerial trapeze, to shuttle steel sections back and forth across the canyon. Step 2, they started building the arch itself, from the bottom up on each side, using massive cables to hold the two halves back until they could meet in the middle. And then, the final step, they literally pushed the flat top deck out from either side, inch by inch, until they met perfectly in the center.
But wait, what about those other problems, right? The earthquakes and the heat? Well, they had smart solutions for those, too. For seismic stability, it turns out the bridge's enormous scale is actually an advantage. It makes the relative effect of the ground shaking much smaller. And for the sun and heat, this is so clever. The rails aren't actually bolted down. They sit in these special fixings that allow them to move, to slide back and forth as the entire bridge expands and contracts with the temperature. Just brilliant.
So, after all of this, after all this incredible effort and ingenuity, you have to ask the question, why? Why on earth build an impossible bridge in the first place? Why pour all this money and brainpower into one of the toughest construction projects in human history?
Well, officially, the bridge is a crucial piece of a brand new 169-mile all-weather rail line into the Kashmir Valley. The stated goal from the Indian government is all about boosting the economy and making travel easier. But it's a politically complicated region, and opponents see it differently. They view it as a way for the state to exert more control. And the price tag for the whole project? Around $5 billion US dollars.
Now, to give you some context for what $5 billion buys you, that same amount of money would get you just 2 miles of the 2nd Avenue subway in New York City. For that price, this project delivered 169 miles of railway, including 943 bridges and 36 tunnels, all built right through the Himalayas. The scale is just mind-boggling. You know, for the people who built it, this was so much more than just a job. This quote from David McKenzie, the senior technical director, really says it all. He says it holds a particular passion for him, that it tugs at the heartstrings, and that he has a picture of it on his laptop to look at every day. That really captures the human side of this incredible engineering feat. Ultimately, the Chenab Bridge is just definitive proof that human ingenuity can overcome these monumental, almost impossible challenges. It shows we really can build in places we were never meant to go. And it just leaves you with one big question, doesn't it? What impossible challenge will humanity conquer next?